SignalFire AI-9 Optical Fiber Fusion Splicer. In this video, we will show how to prepare and splice optical fibers using the SignalFire Splicer and its included accessories. The carrying case also contains a flat cable stripper, a universal stripper, a cleaning brush, a dispenser bottle for isopropyl alcohol, a set of spare electrodes, a set of adjustment keys, a fiber cleaver that allows cutting in a single motion, an AC adapter with power cable, and a carrying strap. The latest version of the AI-9 is equipped with a touchscreen for quick changes of the most important settings, such as menu language, fiber type selection. In this presentation, we will splice single-mode fibers, auto power off time. Additional settings include heating time for heat shrink sleeves, the oven preheating function, and pausing the splicing process. You can also manage splicing triggered by a button, not by closing the lid, the autofocus function, and the battery activation function. Further options include internal tests, cleave angle detection, and the fiber end face inspection type, fiber tensile strength test, factory reset, screen brightness, and manufacturer contact information. Additional functionalities of the Splicer are available via the mobile app, SignalFire 2, available on iOS and Android. Access to some functions requires creating an account. The Splicer connects to the app via Bluetooth. The first function discussed here is the firmware update for the Fusion Splicer. The app checks the firmware version on the device and updates it if a new version is available. Before replacing worn electrodes with new ones, activation is required, which is done by scanning the QR code from the electrode packaging in the app. The final function discussed here is Smart Management. After assigning administrator settings to the device, as shown here, you can set the rental mode and the requirement to connect the Splicer to the app before use. Before each use of the Splicer, calibration is recommended. To perform this procedure, prepare two fibers in the same way as you prepare them for splicing. The outer coating was removed from the optical fiber using the universal stripper. Next, the fiber was cleaned with a dust-free wipe soaked in isopropyl alcohol. The fiber was cut to the correct length using a cleaver. The cut part of the fiber goes into the scrap container. The prepared fiber is ready for calibration or splicing. It's time to start the calibration. Place the cleaved fibers into the Splicer as shown in the video. The fiber should end halfway between the blue V groove and the electrode line. The second fiber, prepared in the same way, goes into the second Splicer holder. Closing the lid initiates the calibration process. Calibration involves generating a series of test electric arcs, allowing the Splicer to adjust the power and temperature of the target arc to the ambient temperature and atmospheric pressure. The icon flashing at the bottom of the screen indicates the need to recleave the fibers to continue the process. The completion of calibration is signaled by an icon change in the upper left corner and a corresponding message. The calibrated splicer is ready for work. Before preparing the fibers, a heat shrink splice protector was placed on one. Inside the protector, there is a metal rod that protects the splice from bending. These fibers were placed in the splicer exactly as during the calibration process. Closing the lid initiates the splicing. Splicing completed successfully, and the splicer displays the estimated splice loss on the screen. After removing the spliced fibers from the chamber and sliding the heat shrink sleeve over the splice, the whole assembly goes into the oven. According to the previous settings, the heating time is 20 seconds. For the purpose of this video, we have quadrupled the recording speed. The tray at the back of the splicer is used to cool the still warm sleeve. An additional function built into the AI-9 is the visual fault locator. When connecting a patch cord to the out port on the side of the device, press the right button. The adjacent button switches the light modes to continuous, flashing, or off. The final function of the splicer presented is the optical power meter. The button marked with the lambda symbol is used to set the wavelength at which the measurement will be performed. A patch cord installed in an SFP module slot in a switch is connected to the in port on the side of the splicer. Once the patch cord is connected, the splicer displays the optical signal power, in this case from the SFP module. Thank you for watching. Please visit our eShop at dipolnet.com.